Okay, so believe it or not, this is actually the informal definition of a limit. There is... Yes. Yes. Yes, that'll be fine. Yeah, if you want to do that, that's fine. Yeah. Okay, let's see. I said I was going to work on this and I forgot. Okay. I can't touch anything. Can't move. Okay. All right, so, given a function f, the limit of f of x as x approaches c is a real number, r, if f can be made arbitrarily close to r by taking x sufficiently close to c, but not equal to c. If the limit exists and is a real number, then the common notation is what we see here. So this probably sounds crazy. I have no idea what any of that means. Let's walk through this, and you have a little taste of what limits mean, so we're going to go through this definition here. So the limit of f of x, and I think I'll draw a picture for this. That helps me sort of picture what's going on here. So if we have just a function, and I'm going to draw maybe something like this, and we're going to call this f of x, right? And so this would be my x-axis here, and I could call this the y-axis, but since I've labeled my function f of x, I'm going to call it the f of x that we have there, right? The limit of f of x as x approaches c. So x is getting closer and closer to c. That means c is somewhere on your x-axis. So we'll call that c right there. Okay. It's a real number r if f of x can be made arbitrarily close to r by taking x sufficiently close to c. So what this means here is that this limit is going to exist if you take, let's see, when you take x sufficiently close to c, but not equal to c. So if I look at over here, my x value might be 1, and it might be 2, 3, 4, 5, whatever number. We don't have a scale here to know. But I'm going to get closer and closer and closer and closer to my x value being c. So I'm taking it sufficiently close to c, close enough that we can tell. Anyway, and I could do that from the left-hand side or from the right-hand side. So if when you do this, that your y values get arbitrarily close to r, so r right here would be the value on your y-axis. So like if we're looking at this point right here, it might be an open circle, it might be a hole, it might be a closed circle, it might just be a continuous graph. But the coordinates of that point would be C and R right there. So if the limit exists and is a real number, what you're going to see whenever your x coordinate gets closer and closer and closer to that C value, that means x is approaching C, the y value will get closer and closer and closer to the R, which is the y value of that coordinate there. Okay? So, whenever we read this here, actually, when we read a limit here, one thing I just want us to do is just like write this out in words, like how do you read this? So, what we're doing is we're taking the limit of whatever is over here as our x value approaches whatever number that we have. So in this particular case, this is asking us to find the limit of x squared plus 7 as x approaches You can reorder the way you say this a little bit. Like if you want to say the limit as x approaches 5 of x squared plus 7, that would be okay. That would be acceptable as well. In fact, I might do it that way on the next one just to show you that that's okay too. But this is how we will read this. Let's look at this next one. What does it mean when I have this little negative behind my A? From the left. So in this case, I could say, let's word it just a little bit differently. We could say the limit as x approaches A from the left of g of x. In this case, we don't have the actual equation for our limit. We've just got the name of the function there. I don't like that way as good, I don't think. I think I like saying as x approaches A from the left at the end. But you could, either one is fine there. So let's look at our next one. Okay. Who can tell me what this one is going to be? Good. This one's going to be x approaches 1 from the right. So it's going to be the limit of, I kind of just like to say the equation first. So 3x plus 2 over x minus 1 as x approaches 1 from the right. So that is limit notation there, writing that out. In this case, what do we have our limit, our x value approaching here? This is infinity. This should be what you are most familiar with because we use these for end behavior, right? So would this be your right side end behavior or your left side? It's going to be your right side end behavior because on that x-axis, positive infinity is over here. It would be negative infinity if it was your left side. So you got your limit at, oh, I'm just rewriting. I don't like writing things out in words very much. But we have to limit of natural log of x plus 2 as x approaches infinity. Can you have x approaches infinity from the right? You cannot, because there is nothing bigger than infinity to approach it. So you won't ever see signs behind those. All right, so I think what's probably a little trickier for these is going from the words to the limit notation. So some of them are still not all that bad. A few of these I think are a little bit trickier. So for 5, it says, given a function f, where f of x equals the square root of x minus 3, find the limit of f of x as x approaches 3 from the right. Okay, so you know you've got a limit. I usually try to look for what my x is approaching. X approaches 3 from the right. So that means I'm going to go ahead, doesn't matter what the function is, I'm going to go ahead and do x approaches 3 from the right. And then you have a couple options here on what you want to do. We need to now think about what we're taking the limit of. And we are taking the limit of this right here. You don't want to put the equal sign in here. You got two options of how you're going to do this. I prefer to just write f of x in a lot of cases. Unless maybe you're working out the problem or something. But I prefer just to call it f of x, and then I don't have to worry about all the symbols and stuff behind it. Just call it the function name. Or it would also be acceptable here to do limit as x approaches 3 from the right of the square root of x minus 3. You don't want to write the whole thing. You don't want to write f of x equals square root of x minus 3 because that would be like, that would make it look like that was the answer to the limit, which we'll see here in just a minute. So you can use either or there. Okay? So for the next one, we've got the limit as x approaches, this time we're approaching 9 from the left. So we put a 9 with the little negative sign behind the 9. And then we're taking the limit of f of x or e to the 2x plus 3. So same thing here. You could just use the function name if you want, or you could do the limit as x approaches 9 from the left of e to the 2x plus 3. Everybody okay here so far? Okay, now, these I think are a whole lot harder because they use that crazy language that we saw in the definition of the limit. And I've seen a few of these questions that they've got like on AP Classroom. I don't know that it's something that's going to end up on the actual AP exam, but they could use this language within a problem possibly. So for a function f of x equals x plus 1 over x minus 3, f of x can be made arbitrarily close to 3 by taking x sufficiently close to 5 but not equal to 5. Okay, so I'm going to put my limit here, and I like to look for what x is approaching. What's x approaching? Is being sufficiently close to 5. So I need an x approaches 5, right? So that shows me where this comes from, right here. Okay, what am I taking the limit of? X plus 1 over x minus 3. Or if I want, and I want to because I don't want to write out extra stuff, I can just call it f of x. That's fine. But I've got another number here I haven't used for anything. Okay, what do you think we should do with that 3? It's equals 3. It's your answer there. So, you know, we've got this part right here. That's our f of x. That's where we get this part. And if you want to do x plus 1 over x minus 3 instead of f of x, perfectly fine. But what f of x is like your y value, what it's getting close to right there is 3. That's your answer on these. The other two we looked at didn't have answers to them yet. They were telling you to find something. So this one is a little bit different there. Okay. All right. So as x approaches infinity, the value of the function f of x approaches 0. So again, in our limit notation, what does x approach here? Infinity. Okay, so we'll have x approaches infinity. What goes over here for our function? F of x. And then I've also got that 0. That's equals 0. Okay, let me show you something that kids do wrong so badly, and I can't remember if I did this for you guys when we did limits or not, but this is wrong, so don't write it down unless you want an example that you're going to cross out and say is wrong. So many kids, when they write a limit, usually within a problem, not just for this, they'll do this. The limit as x approaches infinity is 0. Okay, what's wrong with that? You're not taking the limit of anything. There has to be something here that you're taking the limit of. I like to call this a naked limit. It has nothing that you're taking the limit of. And usually if you put one on one of your tests, well, I guess we'll still have free response. I'll be hand grading some of that. We're going to try to do the other part online. But I will draw a guy looking like this, very shocked that you have just put something so explicit on your paper as a naked limit. It's offensive, really, that you would even think about doing such a thing. So, so be careful for that, because I guarantee you that some of you will do it sometime. I'm warning you right now, like I warn the students every year, and then I grade papers, and I probably draw this little man 15 times on that first limit test, because it's really easy to do. Because you're thinking about the answer, which is 0, and you know, this is in context of like working out a whole problem. So you write this down, and I know that you mean it's the function you were using for that whole problem, but you didn't write it, and can cause you to lose some points. So you want to be careful with that. All right, let's look at this. This is our last one. Yeah. All right, let's look at this last one. As t is made sufficiently close to 6 from the right, the value of a function g can be made arbitrarily close to 2. All right, so in this case, first of all, is there even an x? There is not. What is our independent variable in this case? It's t. Not g, because what does it tell us g is? G is a function. So this is like, they didn't write it, but they could call it g of t here. So we're going to have limit as t approaches. What is t approaching? Okay, 6 from the right. The value of the function g, in fact, I think right here what you're probably going to see is they will probably put g of t. It might be okay with just the g. I like it better with the g of t there to show like what the variable is. That I don't like to just have a g there because it looks like it might be a different variable or something. If you put g of t, you know it's a function where you're plugging in t. And then what is this one going to be equal to? 2. Okay. All right, questions? Yes?
So, when we look at the very beginning, how will we find out, you know, what it's getting arbitrarily close to? Is it like if you pick that point on the x-axis, it's like a point on the line that's closest to that? Like that minimum there?
It is the y coordinate. It's the y coordinate of that point, pretty much. Sometimes that point might be a hole in the graph, so that point doesn't actually exist, but it's the y coordinate of whatever point you're getting close to for that. All right, and I don't know, it probably is not. I got the pen that will let me write on that, or did I get rid of it? Let's see. Hold on. I think I deleted it because it didn't work all that well. Okay. Oh, I know. I'll do this. Let's do. Let me write on the document camera. I'll just write it up here. Put that here. Okay. So extra words. Okay, so f of 1. What do you guys think? Let's see. Yes, that's correct. Sorry, I had to look for a second. We're looking at, I was counting that as 1, so that's what was confusing me, but this is 2. So, in fact, I might add in the halfway tick marks. Now, it might require a little estimation here for this as well, because some of these are not perfect. I try not to put those on like anything I'm actually taking a grade on. All right, so B is looking for the limit as x approaches 1 from the left. So, any ideas there?
I put it does not equal 1.
Okay. All right. Those of you that said 1 are correct, because limits. Now, if they had asked us, well, oh shoot, they didn't really ask this question here. Like, for example, at 1, the value of this function is 0, right? So it doesn't actually equal 0 there. It doesn't actually equal 1, but it's approaching 1 from the left-hand side, right? Because limits don't have to exist at the point, but they have to approach a value. Because what it's a limit, we're going as close as we can get to 1 from the left, but you don't have to exist once you get there. So you can have a limit somewhere where you've got a hole in the graph. Okay? So now that you know that, what do you think about C? The limit as x approaches 1 from the right. It is going to be -1. And in fact, let me go there. So much spaghetti that I brought to school for Math 3. We're using it for domain range. I'm going to use it here. It's like when you're thinking about approaching 1, this is the vertical line, x equals 1, right? So if I travel along my graph this way, as I get closer and closer and closer to where x equals 1, the y value of that coordinate is getting closer and closer to the y value of that place right there where you have a hole. It doesn't actually get there because you have a hole right there, but it doesn't matter because for limits, we're just talking about what you're approaching. So as you go here, get closer and closer and closer to this, then you look at the y coordinate of that point, which is 1. Same thing from the right side. You go to this point right here, you look at the y coordinate for this. So just like doing f of 1, which you guys did a really good job of, you're looking at the y coordinates every time for your answers to these.
So, so like for C, you have to look at that one line. Like you're looking at that line that goes that way.
Yeah, you're trace. It's like you're starting over here and you're tracing your graph from the right hand side. So you're approaching it on the right hand side. Yeah, so like what you're, like you were looking for like bigger x values. So sometimes you might have like crazy stuff happening where it like jumps up and down. You can really just look at whatever's like closest to that point. That's going to be it. So it could do, what happens over here doesn't matter all that much because you're approaching 1 anyway for that. Okay, now what do you guys think about D right here where it says the limit as x approaches 1 of f of x? If I don't have a plus or a minus, it means from both sides. So we already said that from the left side we approach 1, right? The limit as x approaches 1 from the left, that equals 1. From the right, it equals -1. Okay? So can we give an answer for that? There's 2 different answers, right? And what they're saying here is you have a limit from both sides. Those 2 have to equal each other. So since these 2 are not equal to each other, then this limit right here we say does not exist. Okay? So for D, that limit does not exist. A lot of kids like to use DNE as a shortened version of that. I will strongly caution against using abbreviations on the actual AP exam when you turn that in, although I will tell you that they did accept DNE on the past reading, but they probably will for a pretty long time, but there's no list of accepted abbreviations for the AP exam, so it's really better to just write everything out because if you use abbreviation that is not just a common knowledge thing, then they may not accept it. So I just write it out. Although on my homework, I'd probably write D&E for that. Okay, so let's find f of 3. What is f of 3 going to be? 3 is right here. Kind of. It's a little crooked there, but right here. You have a hole, but you also have that dark circle up there above it. So I would agree with those of you that said 2. Okay. Now, so f of 3 is 2. What about the limit as x approaches 3 from the left? So from this side. What is that going to be? It's 1. Because remember, it's okay that there's a hole there. It's just what we're getting closer and closer and closer to. What about from the right-hand side? Also 1. Okay. What about h, which is from both sides? That is going to be 1. So if your limit from the left and your limit from the right meet up, right? If they go to the same spot, then that limit exists, even if you have a hole in the graph right there, right? Okay. The next one says the limit as x approaches -2. -2 is over here. There's our vertical line for -2. As best as I can get it. What do you guys think there? -2. That is correct. Because our y coordinate of this point right here would be -2. All right. We've got x approaches 0. A little less than 1. So this is one that's going to take a little bit of, because we're looking at this point right here, and it's just a solid line, which means it's continuous right there. You could put a closed circle there. You're going to the same point from both sides. So the y coordinate there, let's call it like 0.75 or something, but that's an estimate. That's something I wouldn't give you on a quiz looking for an exact answer. And then we've got x approaches -3 there. What? I think that would be probably good, 0.25. They might have meant for that to be 0, but I don't think it's quite 0. I think it's just a little bigger. Because right there, if you put 0 on that, it would not be the worst estimate that there has ever been. But it does look like it's just a little bit above 0 right there. Okay, so I've got a couple more of these that we're going to do together, sort of as notes, just to get a little more practice, and then we've got a worksheet we're going to do. We've got a worksheet we're going to do, and then the homework will be a delta math. Nobody ever told me exactly, but I know getting schedules together is so difficult. So I've had it 4th period before a few years ago. I like it. Well, I like it better first. Yeah, I like it better 1st period so much. But if I have to have a class 4th period, I'd rather have you guys 4th period than like a low-level class that hates math anyway. So, yeah. Yeah. 2nd period, I think, is the best class of the day because you're already awake. You're awake. You're not starving to death if you got me because you're second lunch. Like you would be in 3rd period, and you're not tired and ready to go home like you are in fourth period, but I don't. A small school is really hard to schedule, really, really hard to schedule and get everybody as much of what they want as you can get. So I don't complain, but I like first period better. Let's see. What am I getting wrong?
I have a question.
Yes.
It's okay if you don't know.
Okay.
So, like, if you have online classes first and second period, you have to come to EHS. Because Ethan didn't come today, guys.
I did too.
But Mrs. Charlotte.
Yes, I believe you do have to be here.
told me I didn't have to.
Well, first of all, teachers can only enter unexcused absences, because we don't have an option of a regular absence, and we have to, if you're not here, we have to mark you absent. I think the only kids that are allowed to just not go to EHS time are kids that like have another class or aren't here for second and third, like the ones next to it. So I think if you have if your third period is on campus, I think of course have you got first lunch?
Yeah,
so that's a problem.
We come to EHS time, go to lunch, and
Yeah, I'd go ask somebody.
I
More.
email the first day
Uh-huh.
to see if the first time I had to come in with EHS time, the status.
Yeah.
She said I don't have to be in school until EHS time. So I assume we have to.
Okay. I think you have to be here. If you got second lunch, it wouldn't matter because you would already be here for third period. It's those first lunch people where you don't want to, you don't want to come in just for that and then have to go to lunch. Yeah, I see what you're saying there.
EHS time, we wouldn't have to come eat lunch here.
Right. Right. You might want to ask someone more important than me to see if that's a possibility. I'm not sure. So, yeah, so. All right, let's see. We need this. Yeah. There's no, like, grade. It's like not like a credit. There's no grade for EHS time, but you are, like, required to be here. So if you were skipping it all the time, you'd probably get, like, ISS or some sort of consequence. So I'd check with somebody and make sure you've got the full, permission not to come if that's the case. All right. Okay. So let's look at a couple examples here just so we have these. And I did these with letters instead of numbers because sometimes that throws kids off whenever they're not the numbers there. So if I have the limit as x approaches a from the left of f of x, so I am looking at, let's put just like a dotted line here. Ooh, wow, that's it's a very thick line there. Oh, that's better. Okay, so I've got that line right there, A. As I approach A from the left, what is my limit? C. Okay, what about as I approach A from the right? It is B. It is B. Because your y coordinate right here is B. It's okay that it's an open circle. It's not included, but you're not going all the way to it. You're just approaching it, right?
Wait, but how do you approach A from the right side? You start at A on the right side.
Oh, you gotta look at that little bitty line and then you.
This line right here. So,
Oh, okay.
Oh.
Yeah.
Okay, that makes sense.
Yeah.
So if you're starting from the right side, you'd be starting from the arrow at that line. Right?
Yeah.
Yeah. Yeah.
Okay.
Okay, so what is our limit as x approaches a of f of x? Does not exist. Okay, so since your limit from the left and the limit from the right do not go to the same place, then that limit does not exist. Okay, over here on the right-hand side, let's just move this line. Oh, let's just move this line over here. All right, as we approach from the left-hand side, what value do we approach? B. What about from the right-hand side? Also still b. And the limit as x approaches a of f of x. B. Okay, but I didn't ask you this, but I should have. What is f of a? Okay. We actually use, the language that we use is a little bit different for asking for the value of the function versus asking for the limit. So limits do not exist. F of a, we would say that it is undefined. Now, that's very close to does not exist. It's just technicality in the language. F of a, we would call it undefined. So the only time you're going to use the word undefined is if you're asked for f of something or g of something, the value of the function. If it is a limit, then you need to say that that does not exist. Okay, does that make sense? So, in both of these cases, we would say that these functions are not continuous, right? We talked about that in pre-calculus. There were different discontinuities we could have, and one of them was a hole in the graph. That made the graph discontinuous. But if the only thing you have is a hole in the graph, the limit can still exist there. Okay. Oh, I did this down here. That's why. So what is our limit as x approaches p of f of x? It is r. Very good. What is f of p? It is going to be q because of this little dot right up here that you probably didn't see if you said undefined. In this one, it would be undefined because there's no other dot anywhere else. But down here on the bottom, there is another dot, so it is defined, but it's still not continuous because that dot doesn't fill that hole.
So like there are two dots and they're both filled, you put both of them?
You probably won't see that because it would make it not a function for that. So they probably wouldn't be using function notation if that were the case. It's a good question. All right, well, okay here? All right, let's do one more and then we're going to do some work. Actually, well, yeah, we'll do this together. All right, I'm going to put my dotted line here because I think that's helpful to see. Oh, such a big dotted line. Okay. All right, so we're starting off with f of a. Xander, what is f of a?
0.
Good. Wonderful. Then, let's see, Webb, f of b. What do you think? It's undefined. If we were talking about a limit, we could probably use infinity there. All right, then we have f of 0. Lexi, what would f of 0 be? G. Very good. That's our y coordinates at that point. Okay, now let's get into some limits. Emma, what would the limit as x approaches 0 of f of x be? None? From the left-hand side, we go to this dot right here, right? And from the right-hand side, we also go to that dot. it doesn't have to be filled in for you to have a limit. You just have to approach that point. So your limit as x approaches 0 of f of x would be the y-coordinate at that point, which is f. So the limit can exist even if you have a hole in the graph. Okay. Let's move over here to number 5. The limit as x approaches a from the right of f of x. Brady, what would we get as the limit as x approaches a from the right? It would be f. Very good. Because you're looking over here at this side. It goes to this open circle right here. Its y-coordinate is f. So right side. Also important that you know your right from your left on these problems. Okay. However, let's see, Maggie, what would we say about the limit as x approaches a of f of x? Nope. What did I say though? Number 6, limit as x approaches a of f of x. I may have said that wrong. If it doesn't have a right, it doesn't have anything behind it, but we don't use the word undefined for limits. What do we say? Does not exist. Especially at first, I usually have a little bit of sympathy on you if you get those two mixed up because they sound so similar. But you want to go towards making sure for limits you say does not exist. For f of something, you'll say that it's undefined. Okay? Correct. Okay. Correct. So from the left side, it would be 0, and from the right side, it would be f, and those are not equal to each other. So we would say it does not exist. Very good. Okay. 7 is a little bit tricky. Let's see. Lucas, what do you think about 7? Limits are not undefined. Limits do not exist. That's an option. Okay. Those are the two options that you have for this. So you can say it's infinity because from both sides there you've got a vertical asymptote, right? And both sides are going to positive infinity. You can say infinity. But remember what we're calling these. We're calling them limits, right? So is infinity really a limit? It is not, right? So another option is, I'm going to use D and E right here because I'm running out of room. It does not exist. So you could use either one. What you'll see on these, like if I give it to you and you write it in, I'll accept either answer. It could be D and E or it could be infinity. If you see it as a multiple choice, I won't have both of them there. So I might have positive infinity, negative infinity, 0, and 1 as answer choices, but I would not put positive infinity and does not exist there because those are both correct for that. Because when you think of limits, it would be like if you were driving down the road and you saw a speed limit sign that said speed limit infinity, right? That's not really a limit in that case. Which I got to experience this summer whenever we went to Germany and went on the Autobahn because it has no speed limit. In parts of the road, they do not have speed limits. In other like they're in town, they have a speed limit, and in other parts of the Autobahn, you'll go like a ways, and there'll be no speed limit, and then you'll come like closer to the city, and then you got speed limits again. And they are serious about their speed limits because we got a speeding ticket in the mail once we got home, because apparently they give speeding tickets from traffic cameras over there. Yeah, so it's got a picture of my husband.
Yeah, it's just a camera, so you'll just like fly through like a work zone or something you don't even know, and then you just get the bill. Yeah. I think we had to pay the bill.
How fast did you guys get? You guys do real fast.
I think we hit it's kilometers per everything's kilometers per hour. So we got up to like 150 kilometers per hour, but that's like 95 miles an hour. Yeah, I felt, from my observation, the vehicle most likely to be going like 110 in the fast lane over there was a Volkswagen station wagon. Like you seemed like I told y'all the other day I kept wanting to see like a Lamborghini just like fly past us going as fast as it could go. Didn't ever see that, but it did seem like if anybody ever really went past you going really fast, it was always a car like that you really weren't expecting to be going that fast. So, but they drove very fast, but it was very orderly. Like, it's illegal to pass on the right hand side of the road, so like if somebody was gonna pass you, they just come up behind you and you get over and they'd go on. Like, they weren't like really like rude, riding your tail. They definitely didn't like whip around you on the right hand side or anything and weave. Nobody was like weaving in and out of traffic, so it was it was pretty cool. But
What kind of car were you driving?
we had a Volkswagen T-Roc, which I don't think they sell in the U.S. It was like a small, very small, they called it an SUV. It was, yeah.
It was called something Mocha. I don't know what it was.
Yeah.
It was like, can't even fit your luggage in there.
Yeah. It was a small, it was like a CRV size, it was like a very small SUV. I hesitate to even call it an SUV, but they called it an SUV because they don't have very big cars over there. Like, there weren't really even hardly any minivans. We saw 2 pickup trucks the whole time we were there. And yeah, they didn't have very big cars. You didn't see. There were a lot of those, like, what is it called? The Volkswagen starts with a T, Tiguan. What are those called?
I think it is.
Yeah, Tiguan. That was like the biggest thing I saw. But, anyway, but it was pretty cool. So they have speed limit of infinity over there. All right, let's finish this up real quick so you guys can get to work. All right, limit as x approaches c of f of x is available. What would that be?
I thought that was an E, so I haven't figured that one out first.
Okay. It is a c.
Is it 0?
0 is correct for that. And then the last one.
Can I do it?
Yes, Xander, what have we got? Yes. Very good. Okay. Is that kind of making sense there? All right, so